Hi everyone, and welcome to Advanced Layout Animations in Compose. My name is Rebecca, and I'm a Developer Relations Engineer working on Compose. And I'm joined by my colleague,
Doris. I'm a software engineer at Google working on Compose animations.
Today, we're going to be talking all about layered animations, and subsequently shared element animations, and a little bit about how they work under the hood.
We have put a lot of thoughts into shared elements. In this talk, we're going to cover the inner workings and design considerations for shared elements. They will help you understand the API choices as well as the behaviors.
So if you haven't done any Compose layout animations in the past, let's do a quick overview of how to perform a basic layout animation. There are many different ways to do layout animations. One of the ways is to use animate DP as state, or animate offset as state, and then manually change the offset modifiers with these animating values. In this example, we change the offset based on a click event. We also know about animated visibility. When used in a column or row, it will animate the size change, and other content will respond to the changing size.
Now that we have seen some examples of layout animations, how do they work under the hood? In this animated visibility demo that we just saw, the top item is shrinking on its way out. Meanwhile, the column observes the change and arranges the item below to move in accordingly. This creates a coordinated effect between the two items. The principle of layout animation is that while a layout animates, it makes its animated size and position observable to the entire layout tree. This allows other layouts to see the changes and respond to the changes. In this case, the column resizes itself and moves the other item in response. That works pretty well, right? Let's dive deeper into this. Now let's look at another example. In this example, all three items are changing size in a flow row. When A and B grow to a certain size, C gets pushed down to the next row. Similarly, item B would also get later pushed onto the next row when there's not enough space for it to fit in the first row. The wireframe indicates item A, B, C's target bounds, and those targets change every frame. The items have a position animation to smooth over the jump to the next row. Since the target is constantly changing, the animation is chasing the bounds. This animation looks overall very reactive. What's causing this? The issue here is that only current animation values are observable in the layout system. There's no way to know the target size or position of other layouts. Therefore, each item has no choice but to calculate its target based on the other's animated value. In this example, B's position is based on A's size, but B can only observe A's animated size. Therefore, whenever A's animated size changes, B's target position changes, and that is every frame. This constant target change is why the animation looks very reactive, and I think you will agree with me that this is not ideal. What if we could observe not only the current value of each layout animation, but also the target value? That brings us to a new feature we introduced in Compose, Lookahead. The design intention for Lookahead is to look past any ongoing animations by observing the target values of these layout animations. Then we can use the target values to determine a stable layout ahead of time, as if all of the animations had already finished. You can see the stable layout indicated by the wireframes in this example. Once we have the stable layout, we could create animations based on the stable layout and avoid interference from size animations. We can compare the two versions of the animations side by side. The left uses Lookahead, the right doesn't. It is clear that the stable layout from the Lookahead helps avoid interference from other animations. Now let's define what Lookahead is. It is a new layout pass. Its intention is to observe layout animation targets and calculate the stable layout. The stable layout typically isn't rendered on screen, except in this case, we indicate the stable layout with wireframes for illustration purposes. Lookahead happens before the standard layout pass, which we call approach pass. The approach pass produces layouts that we typically see on screen. After Lookahead pass, the approach pass will happen frame by frame to animate the layouts. A good metaphor is that hikers need to first look ahead to their destination before they approach that destination. The Lookahead pass gives you the destination of all the layouts, or the stable layout, as if layout animations had already finished. Then during each frame, we'll have an approach pass animating towards the pre-calculated destinations. Lookahead is particularly useful when you don't know the target bounds until layout. In other words, the layout system determines the bounds by measuring and laying out the content. For example, we would like to animate the size and position change for these texts. It would be a lot of effort to manually calculate these bounds. It would involve calculating all the text sizes, the row column sizes, and then the spacing, in order to then finally obtain the positions. Instead, you could access that information calculated from the Lookahead when you build your own layout animations. With the Lookahead, we can use the stable layout as the target of our layout animations. Therefore, we avoid depending on transient changes, such as other layouts' animated size. In this example, we can see that even though the texts are resizing, their position animations move in a straight line from the initial positions to targets. They're not affected by the size animations from other texts.
Now that we understand what Lookahead is and how it helps unlock better animations in Compose, let's take a look at the higher-level SharedElement APIs that are built on top of Lookahead. We're going to be working on the Jet Snack app, an app that allows you to order your favorite snacks. We have two screens, the main content and the snack details screen. We would like to share a few elements from the card to the snack details. If we look in detail at each of the elements we'd like to share between these two screens, we see that there is a gradient background, the image of the cupcake, the title, and the tagline. We'd also like the bounds of the whole card to be shared by growing into the detail screen. Let's see how we can do this. The first composable that we need to use is the SharedTransitionLayout composable. Our UI looks a little bit like this. We have used animated content at the top level between the two screens, and by default, animated content will fade between the two states when the show details variable is updated. So to get started with shared elements, we need to wrap the top level layout with SharedTransitionLayout. This layout provides a shared transition scope, which is responsible for finding the matching elements, doing the lookahead calculations between the two states, and removing the elements from their current rendering position into a layer above the content so it can grow or shrink to its desired size. The animated content composable provides us with an animated visibility scope. This scope is used to drive the progress between the two states of the shared element transition, and it is used to determine what should be displayed on screen at any point. It's worth noting that the animated visibility scope is provided by a few different layouts, such as animated content, animated visibility, or a nav host, which means that shared elements will work pretty well with these different composables. These two scopes are important to understand as they are key elements when using the shared element APIs. The next step is that we need to pass these two scopes to our main content and our details content, as they'll be used to gain access to the shared element modifiers. If you have a large application, you should use composition locals to store these scopes to avoid having to pass it very far down your layout hierarchy. Okay, so the plumbing is set up for our shared elements, but we also need to tag the individual items, which brings us to looking into the shared element modifier. Let's start with the image element first. This is going to be the first element that we share between the two states. In each of the main content and details content composables, we find the matching image composables, and we add Modifier.sharedElement onto each matching item, passing the animated visibility scope and using with shared transition scope to ensure that we have access to this shared element modifier. We also pass in a unique key for the item. You can pass in a data class here, as long as it's unique, which usually means adding an ID if it's within a list. We also add the same modifier onto the matching details content image composable. And with this, we can see that there is a nice simple shared element of the image between the snack and the details screen. Of course, though, we want some more. We'd like to be able to set a custom animation spec, to be able to define how the animation should transition between the start and end state. We'd like it to be a little bit more expressive with a custom spring spec. We can adjust the shared element modifier to specify the bounds transform parameter. This gives us information about the initial size and the target size, and we return a custom animation spec. In this example, we change the spring to have a different damping ratio and stiffness. We need to define this on both shared element modifiers. Now, the animation performs its transition with a little bit more bounce between the two different states. Now we have a basic shared element, let's talk about Modifier.sharedBounds. SharedBounds is similar to shared elements. A lot of the API shape has been kept consistent between the two. The difference as to when you should reach for SharedBounds versus SharedElement is that SharedBounds should be used for content that is visually different, but should share the same area between the two states. It's similar to how animated content works, in that you need to provide enter and exit transitions for the content, as both will be visible on screen during the transition. Whereas with SharedElement, only the target content is rendered on screen. It's useful for things such as cards that transform between different areas, or text, since bold versus italic text isn't the exact same. And asynchronous images, as you may want to load up a high-resolution image as it transforms. So looking at the elements of our SharedElement transition, we have the background gradient. This is slightly different on the detail screen versus the card, so this would be a SharedBounds. The bounds is the whole container, so this should also use SharedBounds. The image, we will continue to use SharedElement here. The title, also SharedBounds because it's text that changes size and it goes from bold to bold italic. The tagline, we will also use SharedBounds since it changes text size. We will just focus on adding it to the bounds of the card for this example. Okay, so we have our main content that lives inside a card. Let's add the SharedBounds modifier onto it. We add SharedBounds with a new unique key and the animated visibility scope. And we apply the same thing to the details content too, applying the SharedBounds with the exact same key as the main content. In this case, it's on a column. So now we have the bounds that transform between the two, and it's looking great. We've also sneakily added SharedBounds onto all the other elements, the tagline, the text, and the background. Notice how the donut word animates from regular to italic text. This looks good, except there's a little bit of an off feeling between the two states. We can see that the end state is a different aspect ratio from the start card size, causing a bit of unequal overlap between the two different size items. So this leads us to talking a little bit about resize modes. There are two options for resize modes: scale to bounds and remeasure to bounds. Scale to bounds is the default set on the APIs. It performs a graphical scale between the two states, meaning it'll retain the same aspect ratio. Notice how in this example, the pink card transitioning has a different bound size from the purple card. The transition between the two doesn't match entirely on top of one another, and the incoming content overlaps the outgoing content with a different ratio. Whereas remeasure to bounds will perform a remeasure and relayout and transform the aspect ratio as it grows between the two. Scale to bounds is useful for things such as text, whereas remeasure to bounds is probably what we'd like in this case, as we'd want the card to grow in size proportionally. So now we've set the resize mode on the card to remeasure to bounds, and the animation is looking a little bit more like it. But you may notice that when performing the animation from a lower portion of the screen, the bottom app bar looks a little bit strange, as the shared element elevates itself above the app bar and then transitions to the final state. This doesn't look ideal. Ideally, we'd like the bottom app bar to move out of the way, but we'd also like to ensure that it will always remain above the content. So how can we fix this? Well, to fix this, we need to learn a little bit about the shared element overlay and how it works. When creating your shared transition layout, an empty overlay is placed at that point in the hierarchy, covering all of the content within that composable. For visualization purposes, we have a translucent red overlay here to show what is in the overlay at any point. When the shared element item is clicked on, the item is also elevated into this overlay, so it's currently drawing above the translucent red overlay. And then the item progressively grows to the target state. And after the transition is finished, you can see that the overlay now has no elements rendering in it, and the content is dropped back down into the original layer that it should render in. So what's happening with this example is that the bottom app bar is not rendering in the overlay. It's rendering in the layer below, which makes it look like the shared element is jumping in front of the bottom app bar as the shared element transition begins. To fix this, we can specify on the bottom app bar that it should also be pulled into the overlay by using the Render in Shared Transition Scope overlay. We give it a certain z-index that it should take on. In this case, we set it to 1, to ensure it's always rendering on top of the shared element. If we set the z-index to 0, the shared elements would render above the bottom bar, but the bottom bar is now drawn in the overlay with the shared elements. In this case, you can see the white background of the card isn't a shared element, so it's not rendering in that overlay, making this look a little bit odd. Whereas when we set it to 1, we ensure it'll render over the other elements, and this is looking way better. But not quite a great experience yet. The bottom map bar is at least rendering above the shared element, but it doesn't move out of the way quick enough. So to make this visual even better, we can add another modifier. Adding Modifier.animate_enter_exit onto the bottom map bar, it'll use the same animated content transition to drive the exit animation. So combined with slide in vertically and slide out vertically, it'll exit the screen as the shared element animation is being performed. It looks way better than their initial rendering. Now the element exits out of the screen. We have applied the same concept to the shopping bottom bar on the snack details too, for it to enter the screen from the bottom of the screen whilst the animation runs. Another visual that needs to be improved in the JetSnack app is that we can see the description text is reflowing as the container is growing in size. Now this is a little bit visually distracting, and we'd prefer it if it didn't reflow as it grows in size. So this leads us to talking about Modifier.skipToLookaheadSize. This modifier allows us to skip the intermediate sizes of the layout animation and skip to the end state that the text will take on. So to solve this issue, on the text composable that's in the snack detail screen, we can add SkipToLookaheadSize modifier onto the text. So even though this isn't an element that's shared, the parent is shared. So adding SkipToLookaheadSize eliminates the intermediate sizes and skips to the target size for the text. This allows us to improve the animation here and remove the distracting reflow of text. So when talking about shared elements, it's useful to understand another concept, which is clipping. Clipping can be thought of as using a cookie cutter to cut content into a certain shape. With shared elements, our child content that was previously clipped may lose its clipping information as it's pulled into the overlay. Let's take a look at an example. In the JetSnack case, we have a rounded corner shape in the main content. And on the snack details, we aren't clipping to a shape, so it's just a rectangle, or a rounded corner shape with a 0 dp radius. With this JetSnack card, we are already clipping the card to a rounded corner shape with a 20 dp size. And when doing a Modifier.sharedBounds on this card, it somewhat works. But because we have inner shared elements, such as the background gradient, all these children are brought into the overlay during this transition. So the children, in this case, the most noticeable child, is the gradient background. It loses its clipping information during this animation. How can we tell that this is a clipping issue though? Well, the item is drawing beyond the bounds of the original rectangle. And in this case, we can see that it's not rounded. So in order to apply the clipping information to our children, we update our composables to have the clipping parameters set on the card and column, so that the children also get this clip applied when you move into the overlay. But you may notice that there isn't an automatic animation between these two states. When it elevates into the overlay, the final target shape is applied immediately between the two, and the animation continues with that target shape applied. So to animate between the two shapes, we need to tie into the current animated visibility scope transition. We use animate DP, and checking the state of the visibility transition, we set the values of the rounded corner card animation to either 0 if it's exiting or starting to enter, or 20 when it's fully visible. We then set the clip in overlay during transition to the rounded corner shape that uses the animated rounded corner value. And on the details content, we do a similar process, but in reverse, since we want the visible state of the details to have no corner rounding. This will give us a nice animation between the two states of our shared element transition. Your imagination can run wild with the possibilities of what can be done if you tie into the shared element transition object. You can use all the knowledge that you already have with animations in Compose here. When working with shared elements, it's important to know how modifier ordering can affect your shared elements. Let's take a look at this example of two shared bounds, A and B. They both contain text that says hello, and we wrap the content with a red border. In A's case, we have the padding modifier as the first modifier. But in B's case, we've put the SharedBounds modifier before the padding modifier. As you can see, when the elements attempt to be matched when transitioning as shared elements, there isn't great consistency between the two states. They don't match 100% accurately. In order to fix this, we move the SharedBounds modifier after the padding modifier instead. What is happening is that all the modifiers after the SharedBounds are considered children of the SharedBounds modifier, in the same way that the text composable is considered a child of the SharedBounds. So in the previous case, when the padding was after the SharedBounds modifier, it was going to be included in the shared element transition. But in A's example, the padding is not included in the transition. So now we understand the basics of shared elements and how to use them in our apps. We're going to add one more final delightful touch to the JetSnack app. You may have heard of Predictive Back before. It's a feature on Android 15 which allows you to display a preview of where the user would navigate to if they were to perform a back gesture. To use shared elements with Predictive Back, there are a few steps. Add the Android manifest XML flag, enable on-back invoked callback. Use the latest version of Navigation Compose, and make sure you're wrapping your top-level nav host in a shared transition layout. Because JetSnack was using nav host, which also supplies an animated visibility scope, we only needed to add the Android manifest option, and we can now get out-of-the-box predictive back animations between the list and element pages. It's worth noting, though, you don't have to use nav host to get this functionality. If you're using your own custom nav framework, you can support this too with a custom predictive back handler and seekable transition state.
Now that we have learned how to use shared element APIs, let's look at what's under the hood. As we know, there are 3 main stages for each frame in Compose: composition, layout, then drawing. Now let's see what shared element transition does at each of these 3 stages. For starters, during composition, new shared content keys are created. Shared transition scope will attempt to match the new keys against other keys created in that scope. Only matched shared elements will animate or render in overlay. A child transition is created for the animated visibility scope. This child transition will be emptied during the initial composition. Later in the layout stage, it will be populated with animations created for shared elements. More specifically, these animations are inter-exit transitions and bounds animations. You might wonder why these animations need to be put in a child transition as opposed to being standalone animations such as animatables. By putting these animations in a child transition, we effectively hoist them into the parent. Therefore, we enable parent transition to control the progress of shared elements. If we look at this predictive back example, you'll see that the shared elements are being seeked as a part of the navigation transition. And that is only possible because shared element animations are in a child transition of navigation. Now onto the layout stage. In this stage, we rely on a custom implementation of approach layout modifier node to handle the different measure and layout logic for the different layout passes for shared elements. Approach layout modifier node is needed for building your own Lookahead-based animations. I'll show you how we implement approach layout modifier node in shared content as an example of building custom layout animations. In the Lookahead pass, we'll calculate the target bounds for shared content. Then in the approach pass, we'll animate shared content from their current bounds to the target bounds that we already calculated in the Lookahead. If we look at the interface definition for approach layout modifier node, we see there's a measure method. This method will only be invoked during the Lookahead pass. In addition to measure, there's also approach measure. As its name indicates, approach measure allows us to define measure and layout logic specifically for approach pass. As you can see, this interface sets up different code paths for Lookahead versus approach. That's how we measure with the target values in the Lookahead pass and measure with the animated values in the approach pass. The separate code paths allow us to prevent animations in the approach pass from affecting the target calculation in the Lookahead. Once the Lookahead pass is finished, each shared content has their target bounds calculated. Here the wireframes indicate the target bounds for all the shared elements that found a match. Now we're ready for the approach pass to animate the bounds. During the approach pass, the layouts will smoothly and continuously move to their destinations. Before going into the details of approach measure, it's helpful to know there are 2 steps of layout measurement, regardless of whether it's approach or Lookahead. Understanding this would help you build your own custom layouts in Compose. Step 1 is measure child content with constraints. These constraints can come from parent or they can be custom constraints. And step 2, report measured size back to parent by returning the measure result. Now let's look at how we measure shared content during the approach pass. As part of step 1, we obtain the animated size of shared content from the ongoing bounds animation. Then we create a fixed size constraints using the animated size. Finally, we measure the child content of the shared element using the fixed size constraints. As a side note, when measuring a layout using animated constraints, we can expect an effect like this. The layout will remeasure its children and potentially relayout them to fit in the animated constraints. Animated constraints could be useful in your own layout animation if you need to resize a layout and adjust everything contained in that layout to the new size every frame. As a result, when we measure shared content with changing constraints, we get a similar visual effect as you see on the right. This is ResizeMode mode. Notice how the text is reflowing to fit in the changing constraints. Since we also know the target size of shared content from the Lookahead pass, we could scale the content to fit in the animated bounds. It is more performant than ResizeMode because we only need to measure the child content once and apply a different scale on each frame, rather than propagating the changing constraints all the way down to the leaf nodes of the child content. This is also the default resize mode. Once we finish measuring the child, we need to report the measured size back to the parent layout. We again have different choices. We could report the content's target size. As you can see on the right, if we report the content size, then the parent will not see any size change during the transition. Therefore, it will not resize itself or rearrange sibling layouts. On the other hand, if we report animated size, then the parent could change their sizes and siblings' positions to accommodate, similar to the animated visibility demo that we saw earlier. In this demo, the parent layout sees the SharedElement's animated size. It resizes itself and moves the other items in the list out of the way in response. It's a good contrast to the behavior on the right, where the SharedElement reports to the parent its target size. The size reporting can be customized as placeholder size for each shared content. Finally, we're on to the drawing stage. Each shared content is rendered in a separate layer, and this enables shared content to retarget the drawing to either the overlay during the transition or the original draw scope after the transition. Their Z order in the overlay by default is the order that they're composed. Z-index in overlay can be used to customize the draw order while in overlay. All right, we have already talked about the overlay in the JetSnack example. Now, since that's a critical part of how shared elements work, I'll show you the inner workings of the overlay and why we use it to help you understand its behavior. You may recall this slide from earlier, where we added a shared transition layout as the parent of animated content in order to obtain the scope to create shared elements. In fact, shared transition layout is also where we create the overlay. If you look at the implementation of shared transition layout, you can see that aside from some scopes that we created, the shared transition layout is really just a box with modifiers. If we zoom into the draw with content modifier, we can see that the overlay is leveraging the draw with content modifier to draw above everything else in the layout. You can think of the overlay as an additional foreground of the shared transition layout. Because the overlay is a part of the shared transition layout, it is the same size and position as the layout. Therefore, whether or not the overlay covers the entire screen or part of the screen, whether it renders on top of the floating action button or underneath the floating action button, that is entirely dependent on where you create the shared transition layout in your app. Rebecca has mentioned some challenges associated with using the overlay. For example, shared elements in the overlay may render over the bottom bar, unless we elevate the bottom bar into the overlay. We have also seen that content gets elevated into the overlay, loses its parent clipping. To fix that, we need to explicitly specify overlay clipping for the content. So why do we use the overlay in spite of these challenges? Interestingly, the reasons that brought the challenges were also why we chose to use the overlay. More specifically, there are three main reasons. One, shared elements need to escape parents' clip bounds, especially when it moves away from one parent into another. On the right side, we have an example of shared elements being clipped by the parent as it moves away from the parent. The red border indicates parents' clip bounds to help you visualize the clipping. The reason number two is we want to avoid having shared elements faded in or out by their parents. When a match has been found, we need the shared elements to stay fully opaque throughout the transition, like the example on the left. On the right side, we apply the parent's alpha, therefore the shared elements phase in with the incoming content. By putting the shared elements into the overlay, we effectively avoid any alpha change coming down from the tree. The last reason is that we need to ensure shared elements render on top of non-shared content. Otherwise, shared elements will most likely render underneath their sibling layouts, like you can see in the example on the right. All right, we have covered the important inner workings of shared elements in three main stages. Hopefully, they offer you a different perspective to look at shared elements and understand their behavior.
Thanks, Doris. We now have our beautiful shared element transition between the snack and the detail screen. and the ability to seek between the two screens with Predictive Back. And we've learned all about how shared elements work under the hood. We have also seen such great examples of shared elements implemented with Compose by members of the community. And we can't wait to see what you can build with these APIs. For more information and examples covering the concepts that we've covered today, plus more information such as API limitations and how to use animated visibility with shared elements, check out the documentation at this link. Happy composing!